So what is the meaning of alpha beta unsaturated ketone? You can understand by taking example this one. Okay, this is the alpha beta unsaturated ketone moiety. Okay, so it is given that in 1,4 addition Gilman from the complex. Okay, so first of all, this reagent from the complex with alpha beta unsaturated compound, or you can say moiety. Okay, and in this copper is +3 oxidation state. It is very important point. If you see here in Gilman reagent, the oxidation of copper is +3. Okay, uh, Gilman also gives 1,4 addition with acetylic carbonyl compounds. Okay, acetylic carbon compound means triple bond attached to the carbonyl group. Okay, and cis addition will take place. Okay, so I have mentioned here that in Gilman copper exists in the +3 state. Okay, while in click reaction there are various types of reagent used in the click catalyst used in the click reactions such as copper sulfate into 5H2O like that. Okay, copper iodide. So in which oxidation of copper is +1. So that's why I have mentioned this one. Okay. So by taking this acetylenic carbonyl group, here I have added the Gilman reagents. Okay, so in this what happened here, this is the, if you see here, triple bond is converted to double bond. Okay, means electron density, if you compare from this one, is reduced in this compound. Okay, so but the, you can see the, this one is group is cis position, means within one side. Okay, as compared to this one. Okay, and the addition of methyl group takes place in the uh, means nucleophilic addition via SN2 reactions takes place in this. Okay, so by this one hydrogen is attached, so by so its valency have been fill up. Okay, so the important point is that its stereochemistry is remain constant. Okay, as compared to the starting material. Okay, so you can see here I have also mentioned the acidic workup takes place. Okay, so acidic workup means H plus is given during the workup, so this hydrogen is attached via this hydronium ion. Okay, so Gilman reagents gives mainly addition reactions on carbonyls. Okay, so first, so this methyl here act as a nucleophilic moiety. Okay, so it will attach from this carbonyl group. Okay, and so after that this charge means this double bond will be break up, and the electron density will be shifted on the oxygen atom. Okay, so this after that what happened, these hydronium ion releases S plus in the solution in the means reaction medium. Okay, and it will this nucleophilic oxygen atom means electron density which is present on the oxygen will capture this hydrogen from hydronium ion and convert it to this compound. Okay, again you can see the it is very important examples. You can see this one. So in this methyl act as a nucleophile and will attack on this carbonyl. Okay, so after addition of methyl on the electrophilic site means carbon atoms, it will convert it to this one, and one hydrogen is abstracted by this oxygen O minus. Okay, so according to the Cram's rule, product will be formed. Okay, so the stereochemistry of this compound is remaining this one, and since hydrogen is present on the 2D plane, so the remaining methyl will be addition takes place and methyl shifted on the waste position. Okay, so on the dash OH will be present. Okay, so in this reaction the product will be this one. Okay, similarly you can see this one. In this what happened here, methyl will attack from this from below side. Okay, because in this if you compare from these examples, in this pH is present in the opposite side, so that's why hindrance is very less, but in this case hindrance is very much, so that's why methyl will attack from the below. Okay, means it will attach from the dash side. Okay, and H plus after workup H plus will be adding here and your product will be this one. Okay, so So according to this, you can see here, first of all, rotation takes place, and after rotation, this phenyl will means its position will be differ, means hydrogen will be come on this pH, okay, and pH will be replaced by methyl, okay, and methyl will be replaced by phenyl, okay. So after rotation you can obtain this product. So in this it acts as substrate, and here methyl will be attached from carbonyl, means electrophilic side, and after that your product will be after workup H plus will be attached. So that's why your product will be this one, okay. So it is very important reaction if you see here, okay. So next one is the reaction of alpha beta unsaturated carbonyl compounds with metal in the liquid ammonia, okay. So liquid means this reagent is very important. Liquid in lithium in liquid ammonia, okay. So ammonia here exists in the liquid form, okay. Lithium is the metal, okay. So addition, so it will reduce the double bond directly, okay. If alpha beta unsaturated carbonyl compound present within the compound, within the cyclic ring or other open chain compounds, so there it will reduce the double bond and there will no effect on the carbonyl group, okay. So again if you see here this compound, so what happened here, this R minus, first of all the double bond will be reduced, okay. And when you will add the lithium liquid ammonia, what takes place, this double bond will be shifted in this single bond, okay. And this carbonyl means the electron density of this double bond will be shifted on the oxygen, okay. So here oxygen further the charge will be reversed, okay. So that's why this here electron density will attracted this R minus, okay. And when you will reaction will be carried out, you will draw the this methyl group on the wedge, okay. So remaining group which will come on the dash side, okay. So the stereochemistry of this substrate, this product will be very important for that. So next one you can see this one, okay. So first of all charge will be migrated, and after that you can see the positive charge will be created because you will reduce the electron density of this carbon. So after there's two lithium, okay. So two lithium is present and it will gives the electron, okay. So two electron will be give, so new, so minus charge will be generated here, okay. So after reverse of this charge, okay, this double bond will be shifted here and minus charge will abstract the R minus, okay. So the remaining group will be on dash, okay. So you will always remember that remaining group will be attached via dash, while other group will attach, near group will be attached on the wedge side, okay. So stereochemistry is very important in this. So if you compare from this, it is actually another example you can see here. So in this carbonyl group, if you add lithium liquid ammonia, so first of all what happened here, charge will be migrated, okay. So okay, so here what happened, these moiety means after reverse of this double bond, this electron density will shift, will attack from this CBR, okay. So this is the p orbital, and here bromine will act as a living group, okay. So that's why what happened takes place, this product will be formed, okay. Always remember this one always on the wedge, okay, and remaining will be the dash side. So reduction of CC bond of alpha beta unsaturated carbonyl compound, lithium or ammonia, liquid ammonia is the best reagent, okay. So it is very important, if you want to reduce CC bond without affecting the carbonyl group, you will add the lithium in liquid ammonia, okay. So again we will discuss the GRIGNARD reagent. It is very important reagent in the organic total organic synthesis, you can say, okay. So any drug during the preparation of any drug, this reagent is very important for addition of any alkyl or other groups, okay. So GRIGNARD reagent is organometallic compound, okay, metal directly connected to the carbon, and it is the best unpooling reagent. So it is also for unpooling reagent, okay. and unpolar reagents be reversible in polarity. Okay, so if you prepare of Grignard reagent, you should use the alkyl halide. Okay, and magnesium metal will be added in the reaction medium, and here reaction medium is act as a dry ether. Okay, so RMgX will be formed here. Okay, so mechanism takes place where if you see here R plus and X minus, and Mg via reduction via reducing two electron, it will be converted to Mg2 plus. Okay, so Mg2 plus here act, so after that R plus capturing the this R plus capturing the two electron. Okay, and converted to R minus. Okay, and this R minus attached from the Mg2 plus forming the RMgX. Okay, so here charge will be reversed. Okay, so in Grignard reagent dry ether is used, you will consider the dry. Okay, so before using the ether solvent, you will dry the ether. Okay, in by using the calcium hydride and other COCl2 like that. Okay, so there are lots of you can use the sodium benzophenone. Okay, so there are lots of drying agent will have been used in the during the dry of any other any solvent, you can say either ether or THF. Okay, so ether solution Grignard reagent exists in the following type. Okay, so you can see in solution form it exists in the chelating form, means magnesium will attach from Rx and ROR. This is the ether, and this is the alkyl halide. This is the actually RMgX. Okay, again means Grignard reagent, and ether solvent will be attracted by the magnesium 2 plus. Okay, so it exists in the solution. Okay, so again you can see in ether solution Grignard reagent exists in the following equation. So two RMgX forming the reaction is irreversible. So R to Mg and Mgx2. Okay, so two component will be formed here. Okay, and it is called slang equilibrium. Okay, so the formation of Grignard reagent, the redox reaction. In Grignard reagent there is a polar covalent bond in between carbon atom and magnesium. Okay, so reactivity always you can say iodine is bulky group, so it is acts as a best living group, so that's why its acidic strength is much more. Okay, and towards if you move from iodine to fluorine, it is the strongest bond will be formed by the fluorine. Okay, and weakest bond formed by the R minus, means iodine will be released out very easily. Okay, so write the correct order of formation of Grignard of the following alkyl halides. So tertiary, then secondary, then primary. Okay, so first is more suitable because after formation of Grignard reagent, R minus is more stable than tertiary R minus. Okay, so RCS2 minus is formed, which is more stable, and R3C it is less stable. Okay, so stability either you can see this one. Okay, tertiary will be the less stable and primary is the more stable. Okay, so you will also see these vinyl halides. Vinyl means C and X will be any halogen. So it is the vinyl moiety and it is the allyl halides. Okay, so allyl is the means CS2. This is the CS2 and there is no another carbon. Okay, so these double bond is difference is you can say separated by the CS2, but there is no CS2 bond. Okay, so in the case of vinyl halide, there is a double bond. Okay, and double bond character in between carbon and X, more amount of electron required to break CX bond. Okay, so high temperature is required. Okay, and in these cases ether cannot be heated, so tetra THF used as a solvent. Okay, so in this you can say these halogen containing the lone pair of electron which will be transferred from this single, means it is converted to double bond, and the charge density will be shifted to the CH2 minus. Okay, so similarly you can see this one. Okay, so when you will add in this Mg means RMgX in THF solvent, the product will be this one. Okay, means okay, so and if you add here magnesium triether, no reaction are very low yield. Okay, so 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 why actually in this case if you see THF gives the but dry ether no reaction takes place. Similarly, you can see Mg, if you reaction is carried out, this compound with one equivalent magnesium in THF solvent, then bromine will be formed here, means Mg will be replaced. Sorry for that, this is the substrate, okay, and when reaction is carried out, Mg will be means MgBr will be formed. So it is the Grignard reagents, okay, and when reaction is carried out, Mg ether, then MgCl and MgBr will be formed, okay. So here bromine is much more reactive if you use THF, but when you use ether, both MgCl and MgBr, means in chlorine and bromine, magnesium will be addition takes place, means ether is okay. So it is the means different, means you can say difference when we will use either THF and ether, okay. So in both solvent, the product form will be the different, okay. So 1,2 dihalides are not used to form Grignard reagent because they gives the elimination reactions, okay. So you can see in this, elimination takes place and double bond will be formed here, so it is called E2 reactions, okay. So when you will use iodine in acetone solvent, olefinic moiety or double bond will be formed here, okay. So 1,3 dihalides are not also you can see 1,3 dihalides are also not used to form Grignard reagent, okay, because they gives the substitution reactions. So what is the meaning of substitution? First of all, magnesium will be inserted in between CH2 and X, okay. So after that, this double bond migrated to CH2, means on the CH2 electron density is much more, okay, and it will transfer own electron density to near CH2 and X will be released out. So that's why after SN2 reactions, the epoxide ring will be formed, okay, and MgX2 will be released out. So similarly, you can see in this, magnesium will be inserted in between these, okay, and here triple, means benzene ring will be formed, okay, and MgX2 will be released out. And it is very important point, meta and para dihalobenzenes can form the Grignard region. So if reaction is carried out, this bromine, this is the benzyl bromide, and when reaction is carried out with magnesium, okay, so MgBr will be formed, and after that, you can see here, uh, after that you can see Mg, this will form the dimer, okay. So dimerization takes place. After formation of this, it will react with another benzyl bromide and form the this dimer, okay. So it is geo products. So in next lecture we'll describe the reactions on reactions of Grignard reagents, okay. So it is, so in this I left there, okay. So thank you for all.